Assalamualaikum. This is Chapter 12, Monopolistic Competition and Oligopoly. Today we're going to look at monopolistic competition and another market, which is oligopoly. We look at monopolistic competition first, and these are some terms that I'm sure you have seen it in the first year, especially in the principle of microeconomics. Like I said just now, we look at the monopolistic competition first. This is the third market that you have seen from your first year. Okay, so when we talk about monopolistic competition, recall back all the characteristics and also why it is called competition. Roughly speaking, it is called monopolistic competition because there are many firms in the industry or market, but not as many as firms in the pure competitive market or in the perfect competitive market. Okay, so when we talk about monopolistic competition, okay, what makes a market becomes a monopolistic competition market? So it has two main characteristics. The first one, firms compete by selling differentiated products that are highly substitutable for one another, but they are not perfect substitute. Okay? In other words, the cross-price elasticity of demand are large but not infinite. So if we have two goods, X and Y, okay, it must be more than one, isn't it? Okay, and very, very high, but not infinity. Okay, so X and Y are substitute to each other. So whenever price of X increases, people goes to Y, but not all people will go to Y. Okay, now the second key characteristic or the main characteristic is that there is free entry and exit. So it is relatively easy for new firms to enter the market with their own brands and for existing firms to leave if their products become unprofitable. Okay, so it means to open any firm in this monopolistic competition market is easy. So the cost is relatively cheaper than other types of market, such as monopoly, okay, because it doesn't have economies of scale, for instance. But then if the market is making losses because of certain, let's say disturbances in demand, reduce revenue, therefore increases the loss, then it is also easy for any firm to exit from the industry if that firm is making losses. Okay, so here, because of this free entry and exit, then it has some implication in the short run and long run. Okay, so you want to look at the equilibrium in the short run and long run for a monopolistic competitive firm. So we have a frame of diagram here, we have price here, and we have quantity here. So I'll show you. So let's say we are talking about the short run first, yeah. Demand for the monopolistic competitive firm looks like this, and therefore the marginal revenue below the demand. Okay, and let's say marginal cost looks like this, and let's say we have, I'm just making up here, AC average cost that looks like this. Okay, so profit maximizing rule says what? MR equals to MC. So MR equal to MC here in the short run, and therefore we can find the price that maximize profit, which is P1. Quantity is here, Q1. As you can see, at Q1, average cost per unit is here. Okay, AC1, for instance, yeah. Therefore, this firm is making profit. The existing firm in the market is making profit. And because of that, then other firms outside the industry find it is profitable to make business in this industry. Let's say we're talking about cake, baking cake industry. Yeah. So when other firms enter into the industry, you imagine this is the industry. So you already have some number of firms here. So other firms enter, the market share of each of the firm becomes what? Becomes smaller, isn't it? So when the market share of each firm becomes smaller, so you could expect, demand for each of the firm becomes smaller as well. Smaller means what? Smaller means demand shift downward. Okay, so demand shift downward, let's say somewhere here. Okay, so let's say this is the new demand, and then the new MR is this one. Okay, so MR equal to MC is here. Okay, and the new price is here, P2, and then quantity is here, Q2. And as you can see, P2 is actually equals to AC, isn't it? Okay, and in this case, after some time, okay, then we have normal profit for each firm. So can you see? Easy entry eliminates profit. Initially, you have darkened, rectangle, which is profit for this firm. But then because this firm is making profit, other firms outside the industry enter into the industry. Then makes market share for each firm becomes smaller. When market share for each firm becomes smaller, demand falls down for each firm, isn't it? Because now you have to divide the same number of customers into many firms, isn't it? Okay. Now, so because of that, when demand decreases, MR equal to MC is the new one at this point. Call it point B. This is point A. So price reduced from P1 to P2, and P2 here is so happens to be equal to AC. And in the long run, after adjustment, after the decrease in market share, we can see that each of the monopolistic competitive firm in the industry or market is earning normal profit. Okay, so you can see here, easy entry eliminates profit. In the short run, you can have profit, but in the long run, because of easy entry due to profit, all firms have smaller market share, and it eliminates the economic profit in the short run that already have in the short run. So everyone is earning normal profit. What about if in the short run, the existing firm, each of them is making losses? Can you analyze this? What will happen after that, and what will happen in the long run to the profit? Will it be losses all the time? Okay, so I want you to do this at your own time, because from here you can see, because of free entry and free exit, you can see in the short run any firms can make profit or loss, but in the long run they will always, each of them that still live in the industry will always make normal profit. Okay, now the next thing about monopolistic competition is that we need to look at the level of efficiency. Okay, so in order to look at the level of efficiency for monopolistic competition, we always compare it with the ideal one. What is the ideal market? The ideal market is perfectly competitive market. So I want to compare monopolistic competitive firm with perfect competitive firm in one diagram so that I can measure economic efficiency of monopolistic competitive firm. Okay, so I use this graph. Now, price is on the vertical axis, quantity is on the horizontal axis. I have demand curve for this firm. I have marginal revenue curve. Okay, and I have marginal cost. Now, let's say I have my AC curve that looks like this. Okay, alright. Now here, when we compare and we between monopolistic competitive firm and also perfect competitive firm, and when we want to measure economic efficiency, we use long run analysis, not short run. Why? Because in the long run, the results of profit, price, and quantities for each of the firm is stable, isn't it? Because in the short run, for monopolistic competitive and also perfect competitive, they can have profit, they can have losses. So it's not easy for us to analyze. But in the long run, we know that both of them have um, normal profit. So let's begin analyzing them. For monopolistic competitive firm, okay, maximizing profit is MR equal to MC in the diagram, isn't it? Where is it? It is here. When you drag up the line, then it hits the demand curve, then you can find the price PMC. As you can see, PMC also hits AC, and in this case equivalent to AC1, let's say. If you drag down the line, then you can have quantity. I call it quantity QMC. Now, I want to compare with perfect competitive firm. For perfect competitive firm, maximizing profit is always MR equal to MC. And we know that at this point, it has, maximized profit. And at the same time, here it is equivalent to minimum AC, isn't it? Where is minimum AC? It is here. Okay. Now, so in this case, minimum AC is here. Therefore, perfect competitive price is here. And is equivalent to minimum AC. Where is the quantity? Quantity is here. So let's say I fix the drawing. It's not nice though. So QC is here. Now can you see? PMC is higher than PC, but QMC is lower than QC. As you can see, when PMC is higher than PC, it means PMC is higher than minimum AC as well, isn't it? As you can see, minimum AC is here, but PMC is here. Can you see higher? Okay. That means, for the first one here, when the price charged by monopolistic competitive firm is higher than the minimum AC, that means they get revenue more than cost, isn't it? And in this case, although they have normal profit, but it's not at minimum AC. When the price charge is not at minimum AC, that means monopolistic competitive firm is not producing at the cheapest cost, because the cheapest cost means what? Minimum average cost, isn't it? The minimum cost possible. With this situation, that means monopolistic competitive firm is not achieving what kind of efficiency? Productive efficiency. So in terms of economic efficiency, the first type of efficiency is not achieved by monopolistic competitive firm. What about the second one? The second one, we found that QMC, which is quantity produced by monopolistic competitive firm, is less than QC, quantity produced by perfect competitive firm. That means this firm hasn't produced using the allocated resources, fully. Why? If it has used all the allocated resources fully, they should produce more, like perfect competitive firm. Okay, at QC, it produces less than what it should produce. So in this case, When QMC is less than QC, allocative efficiency is not achieved. So what can you say now about monopolistic competitive firm? Is it, achieving economic efficiency? Obviously, no. Okay, because if it achieves, the price charged and also the quantity produced should be the same as the ones, by perfect competitive firm. Okay, so that's the thing. So here, before I forget, yeah, under perfect competitive, price equals to marginal cost. You can see here, at this point, price equal to marginal cost equals to minimum AC. And if you see the red line here, then this one is the demand curve for a perfect competitive firm. Alright. Another thing that we need to look at when we talk about, monopolistic competitive firm is that the dead weight loss. So here, I can show you in the form of graph. Price is here, quantity is here. So let's say demand for this firm is downsloping. As you can see, demand and also marginal revenue curve for monopolistic competitive firm is almost the same as monopoly, but it is more elastic, isn't it? Can you recall back why it is more elastic than monopoly firm's demand curve? Recall back all the things that you have learned in the principle. Now, let's say marginal revenue looks like this. Marginal cost, sorry. And average cost looks like this. Okay. Let me fix the drawing. Okay, easy. Now, MR equal to MC here, and then QMC here, and then price is here, isn't it? PMC. If you look here, there is a dead weight loss. Where is the dead weight loss? The dead weight loss is actually this triangle. So because the dead weight loss exists, then in this case, monopolistic competitive firm is not efficient as well. How to calculate this dead weight loss in mathematics here? You need to see a lot of exercises from the textbooks and see how it is done. Yeah, I'll just show you the generic form in the form of graph here. All right, now can you think of any examples of monopolistic competitive industry? And what kind of elasticity of demand for the product of this example? One good example is shampoo. Shampoo is just a shampoo. You use it to wash your hair, innit? But as you can see in the market, there are so many different types of brand of shampoo, such as Pantene, Rejoice, and so many things. Some people, they use Pantene, and if we request them to use Rejoice, they don't want. We cannot say that it's just a shampoo, you can use, Rejoice. No. They would say no. Why? Because they have brand loyalty. And some would say that if I use Rejoice, then I have, split at the end of my hair. But if I use Pantene, I don't have such kind of problem. And you can see that the shampoo is differentiated based on brand, isn't it? Pantene, Rejoice, Sunsilk, and whatnot. And it is also differentiated based on, how comfortable you are when you use it, when you wash your hair, whether it suits you or not. Because of the ingredients used is different, is differentiated. Can you see? And because of this, it creates some degree of loyalty among customer, and that allows the monopolistic competitive firm to manipulate the price. Okay, then they have market power in this case. We are done with monopolistic competitive firm in general. Now we move to oligopoly. Now when we talk about oligopoly here, I'm sure you have seen all of these characteristics when you were in the first year. The products may or may not be differentiated. What kind of product can be differentiated? What kind of product cannot be differentiated when we talk about oligopolistic market? Okay, as you can see here, I told you earlier, monopolistic competitive firm, the number of firms are many, but not as many as perfect competitive in the industry, isn't it? But what about oligopolistic market? You can only have few firms, okay? It's not like 1 million firms in the world. It's like, maybe 100, 200, 1,000 only, okay? And in some oligopolistic markets, some or all firms earn substantial profit over the long run. Why? Because of the barriers to entry. And the barriers to entry here make it difficult or almost impossible for other firms to enter into the industry. Even if the existing firms in the industry already make profit and you are interested to enter, you cannot enter because of the barriers to entry. What are the examples of barriers to entries? So please read back your principle of micro. Now, oligopoly is a prevalent form of market structure. So examples like automobiles, steel, aluminum, petrochemicals. Can you see all are very difficult to produce? So when they are very difficult to produce, it means they need technology, isn't it? High-tech production. And you need to have what we call economies of scale. And in order to achieve economies of scale, you must produce a lot. To produce a lot, you must use high-tech technology. And that one is very costly. That makes it becomes a barrier to entry. That's one possible reason, yeah? And other reasons as well. Okay, so when we talk about oligopoly here, another good example, especially in the USA, is, perhaps some of you won't believe it, is the cereals industry. Okay, cereals industry. Kellogg's Cornflakes, Lactel, and whatnot. All of this, they are oligopoly. They have competition among each other. Okay, so when we talk about oligopolistic market, how do they find equilibrium here? There is one kind of theory that is related to oligopoly market, and it is a very famous theory. You must understand, in the oligopoly market, you have few firms. Let's say firm A, firm B, firm C, firm D, for simplicity. Although you have few firms, but you still have competitors or rivals, isn't it? So because you have rivals here, just imagine if you sell something and your price is equivalent to 2. And suddenly firm B wants to reduce your price to, let's say, 180 bucks. Okay, what would you do? Just stay quiet? You won't, because you understand that when he sells at 180 bucks, everybody will go to him and purchase his product, and nobody wants to go to you. So you start to reduce the price, let's say to 170, and so on and so forth. Okay, so you try your best to get the market share, and then you try your best to maximize your profit, given your competitor is also doing the same thing. So whatever you do here, whatever profit you get is also depending on whatever your rivals or competitors is doing. Whatever profit that your competitor receive, and whatever action your competitor wants to do, his profit and action also depends on what you want to do. Okay, so once you reach equilibrium in the market of oligopoly, firms actually are doing the best they can and have no reason to change the price of output once they reach equilibrium. There is one kind of theory in equilibrium for oligopolistic market. We call it Nash equilibrium. For Nash equilibrium, it says equilibrium in oligopoly markets means that each firm will want to do the best it can, given what its competitors or rival are doing. And these competitors also do the same thing, will do the best they can given what that firm is doing, because each and everyone is rival, isn't it? Therefore, Nash equilibrium is a set of strategies or actions in which each firm does the best it can, given its competitors' action. I'm doing the best I can given what you're doing because I want to maximize profit. Same to you. You want to maximize profit also. So you do the best what you can given what I'm doing, because if I reduce the price, for instance, I think that I can maximize profit. But at the same time, I must know your reaction, because once you see I'm reducing the price, of course you will reduce the price also. In the first place, I thought that I can maximize profit. But when you react that way, then the market share won't move to me too much, isn't it? So at that point, my profit, I expect that it will increase exorbitantly, but it's not. It increased, but not that much, for instance, because you react with what I did just now. Okay. So like I said, in the oligopoly, we have few firms, firm A, B, C, D. At least we must have two firms competing against each other. If you becomes one, then you become one monopoly, isn't it? So we don't call it oligopoly. If you have two firms only in the oligopoly market, then how do you call this oligopoly? We call it duopoly. Duopoly is a market in which two firms compete with each other. Next, we want to look at different types of oligopoly model. The first one is Kuhn. The second one is price leadership or Stackelberg model. And the third one is Bertrand model. Have you heard all of these models before? I'm sure all of them are something new to you. So when we talk about Kuhn model, we go to the first model here. What is Kuhn model? It is basically an oligopoly model. And in this oligopoly model, which is Kuhn model, every firm produces a homogeneous or identical good. And each of the firm treats the output of its rival as fixed. Okay, that means if I am firm 1, you are firm 2, I think that you're producing 50 currently, not more, not less. Okay, and you as firm 2, you think that I'm producing, let's say, 100, not more, not less. And next, all firms in this Kuhn model will decide simultaneously on how much to produce. Okay, the way I decide to produce is at the same time taking into account how much you produce as firm 2. You, firm 2, the way you decide how much you want to produce, also taking into account how much I, as a firm 1, wants to produce. So in this case, it means firm 1's profit maximizing outputs, my output, that can help me to maximize profit, actually depends on how much I think you as firm 2 will produce. Okay. So here, I'll try to show it in a form of diagram. And this form of diagram is just for understanding. It's not a very formal one, but it's just for, the beginning of the concept of Kuhn model. So we use this graph. Now remember, let's say I am firm 1 and you are firm 2. Now I'm considering about how much I should produce given what you produce, what I believe you produce. Okay, so this graph is meant for my firm output decision. So this one is, okay, firm 1 output decision. Yeah. So let's say price for product that I produce is here, P1, and quantity that I produce is here, Q1. For simplicity, let's assume that my marginal cost is constant. Therefore, when I draw it, it is a horizontal one. So when it is constant, it is a horizontal one. It means regardless the quantity of output, my marginal cost is always the same for each level of output. Okay, now, like I said earlier, my profit maximizing output depends on how much I think you, firm 2, will produce. Now let's begin. If I think I am firm 1, if I think that you, firm 2, produce Q2 equals to 0, then I, as a firm 1, okay, will face a demand, this demand, look at the drawing, and this demand, the demand that I face, given that I think you produce 0, and the associated marginal revenue for my demand here is this one, MR. Okay, let's call this one MR1. When you, firm 2, produce nothing. And all of us know that the condition to maximize profit is MR equal to MC, isn't it? In this case, MR1 when you produce 0 must be equal to MC1 for my firm. So where it is here. If I drag down the line, drag up the line, then I get the price. But I don't want to label the price because it becomes a mess. I just want to label the quantity. So the quantity that I will produce here is, let's say, 50. Now, so firm 1, quantity 1, I produce 50. This is the first one. Now, let's say, if I am firm 1, okay, I think you as firm 2, instead of producing nothing, you want to produce 50. Okay, so I, firm 1, will have lower demand, isn't it? Because you produce 50, why should I produce too much? Because otherwise, you know, I produce too much. I get excess, and then I cannot make a lot of revenue. As a consequence, then my demand curve will look like this. Okay, so this demand curve, I use different pen here, is T1 when you produce 50, and the associated marginal revenue is this. Okay, so this one is MR1 when you produce 50. Profit maximizing condition is what? MR1 when you produce 50 equals to MC1. This is for me. So the quantity that I'll produce is here. Let's say 25. The price is here. I don't want to mess the graph. Okay, now next, if I think you as a firm 2, you want to produce, let's say 75, what should I do? I reduce the demand, isn't it? Then my demand becomes, let's say, this one. Okay, so I use different pen. D1, 75. Okay, the associated MR is this. So this one is MR1, 75. Profit maximizing condition is here. Let's say 12.5. So here, maximizing profit, MR1, 75. My maximizing profit is MR1 when I think you produce 75 equals to MC1. So the quantity that I'll produce is 12.5 reduced. Let me fix this one. This is not F1, yeah? This should be Q1. Alright, and before I forget, for my firm here in second one, Q1 will be what? 25, isn't it? As you can see, you look at my reaction. When I think you produce 0, I produce 50 to maximize my profit. Second, when I think you start to produce something which is 50, I react. My reaction can be seen at the quantity I wish to produce, which is 25. I reduce my production in order to maximize my profit. Okay. The third one, I also react. When I think you produce 75, I react by reducing the quantity that I should produce just to ensure that I maximize profit. So my reaction here is after I think what you want to produce. Okay, given that you don't change in terms of production, that's what I think. Okay, the same goes to you. So here we can see that I, as a firm 1, react based on how many I think you, as firm 2, will produce. Okay, from here we can come up with what we call reaction curve. So what is a reaction curve? It shows you the relationship between a firm's profit maximizing output and the amount it thinks its competitor will produce. Okay, so here, after I have this kind of information 3 here, all of this, then I can show it in the form of graph, more formal one. This is reaction curve. Okay, so the reaction curve is shown by how much each firm produce, taking into account how much other firm would produce. Okay, so reaction curve in this graph, I put Q1 on the vertical axis, I put Q2 on the horizontal axis. Okay, now here, if you recall back all the information that I have for myself, when firm 2 produces nothing, firm 1 produces 50. Okay, so nothing is 0 here. 50, let's say somewhere here. Okay, and the second one is 25 for firm 1, isn't it? When firm 2 produces, let's say, 50. And the third one is, let's say, 12.5 when firm 2 produces, let's say, 75. And then if I extend this curve, okay, I can extend it here. Then the last one would be, let's say, 100 here when firm 1 doesn't produce anything. So I join all the point here to get a curve, and this curve is how I, as firm 1, react when firm 2 produce a certain amount. So the way I react is, being depicted by the amount I want to produce, and the amount or the quantity that I want to produce depends on the quantity that you, as firm 2, want to produce. Okay, so this is basically my reaction function, and my reaction function here is actually Q1 as a function of Q2. Okay, so firm 1 reaction function. Okay, similarly, we can also draw firm 2's reaction function. So let's say it is somewhere here. Let's say, yeah. So this one. Okay. So let's say this one is firm 2's reaction function. It is the quantity firm 2 produces that depends on quantity firm 1 produces. Okay, you see here both of them intersect at this point, and whatever quantity here and whatever quantity here. In the study of oligopoly, when both of these reaction functions intersect, this is what we call equilibrium. Now, this equilibrium is basically what we call Coulomb equilibrium. Okay, so here I have shown you the Coulomb model by plotting the graph like the way we did in the high school. And it takes time actually. Let's learn Coulomb model formally. When I teach you Coulomb model formally, we have two things. Number one, the mathematical form of Coulomb model, and number two, the graph. Okay. In order to learn this, we need some information about firm 1 and firm 2, production function, especially when it comes to the cost function, not the production function itself, but the cost function, and also the demand in the market. So here are the information that we need to have. For simplicity, at your level, when we deal with mathematics, we only deal with linear demand curve. So when we deal with linear demand curve, the mathematical derivation is very straightforward. If it is non-linear, then you have to use, second order derivative to check, maximum and minimum points, how many it is and whatnot. Okay, but if it is linear demand curve, you know that the second order, the second differentiation of the, any kind of curve, be it marginal cost, be it, marginal revenue and whatnot, is always linear, and the slope is always positive, and then the second derivative is always 0. Okay, so for simplicity, let's say we have a market which is oligopoly market. You already understand that to be an oligopoly market, it must have at least 2 firms in the industry. Okay, if it is one, then it's not oligopoly. It is called monopoly. So for simplicity, we have 2 firms. Okay, let's say firm 1 and firm 2. If we have 2 firms in the industry of oligopoly, then we call it duopolies. These 2 duopolies face the following market demand curve in expression 1, P equal to 30 minus Q. Also, for simplicity, for the introduction of a Coulomb model, let's assume that marginal cost for each of the firm is constant and 0. Okay, so here the question is, given these 2 firms in the industry and each of the firm wants to maximize profit, we want to know, okay, what's the price each firm will charge? What's the quantity each firm will produce? Okay, and to do this, we need to follow the profit maximizing conditions for each of the firm. Let's begin. So we have market demand curve in expression 1, P equal to 30 minus Q. Okay. For the case of Coulomb model of 2 firms, we want to decide Coulomb equilibrium basically. So we'll do it step by step. As you can see here, first, we need to find firm 1's reaction curve. Second, we need to find firm 2's reaction curve. C, we need to find Coulomb equilibrium. And D, we need to find total quantity produced. I also want to add another one here. Find the profit for each firm. Yeah, okay. So how do we do this? We do it one by one. Let's begin with firm 1. Okay. If you look at the market demand curve here, P equals to 30 minus Q. Q here, the total demand in the market for both firms. Okay, because in the market, you are not alone, because we have duopolies here. As a consequence, here, it implies that Q equivalent to Q1 plus Q2, isn't it? Quantity produced from firm 1, demand for firm 1, quantity for firm 2. Okay, now let's begin with firm 1. We need to find the firm 1's reaction curve. We already know that for firm 1 to produce, firm 1 will follow profit maximizing condition. So here when firm 1 decide to produce, firm 1 must decide in such a way that firm 1 can maximize profit. However, at the same time, we can see that firm 1 has a competitor, which is firm 2. Then firm 1's decision to produce, taking into account, maximizing profit, must also taking into account what firm 2, how much firm 2 will produce. Okay, because we have interdependent concept in the oligopoly industry. What I produce, whatever profit I receive, depends on what my competitor is doing, isn't it? Now, so here we need to find total revenue for firm 1. As you can see, let me start all over again. So P here equals to 30 minus Q1 minus Q2, isn't it? Okay, so total revenue for firm 1 is actually P times Q1, isn't it? And to be more specific, it is actually 30 minus Q1 minus Q2 multiply the whole thing by Q1. So if I write it nicely, total revenue for firm 1 becomes 30 Q1 minus Q1 square minus Q1's Q2, isn't it? We already have MC1, which is 0. In order to maximize profit, we follow profit maximizing condition. Okay, marginal revenue for firm 1 must be equal to marginal cost for firm 1. Okay, so we need to find marginal revenue for firm 1. What should we do? We need to differentiate total revenue for firm 1 here with respect to Q1. How do we do it? Delta TR1 over delta Q1. This is a very simple differentiation that you have learned in mathematics in your first year. So 30 Q1 becomes 30. Minus Q1 square becomes minus 2 Q1. Minus Q1 Q2 becomes minus Q2. Now this is actually marginal revenue for firm 1, isn't it? We already found marginal revenue for firm 1. Next, we need to follow the profit maximizing condition. We equate marginal revenue for firm 1 that we calculated here with MC1, which is equivalent to 0, which is given in the question. So here we have 30 minus 2Q1 minus Q2 equals to 0. Okay, so if we rearrange this, remember we need to find firm 1's reaction curve. So when we rearrange it, you get 2Q1 equals to, what is it? 30 minus Q2. Then Q1 equals to 30 over 2 minus 1/2 Q2. Right? So if I simplify it, then it becomes Q1 equals to 15 minus 1/2 Q2. This is what we call firm 1, okay, reaction function or curve. Can you see the way firm 1 react to firm 2's production at the same time is also taking into account profit maximizing condition? Because logically speaking, for any business person, yeah, you want to maximize profit, but at the same time you have to take into account what your competitors are doing. Or in other words, you must also look at what your competitors are doing, but at the same time you also want to maximize profit. So we have two things here: maximizing profit and our reaction towards our competitors. Can you see? Firm 1's reaction function depends on firm's 2 quantity, isn't it? So here in generic form, Q1 is a function of Q2. Alright, so we have done part A here. What about question B? Firm 2's reaction curve. You do the same thing. You need to do it the same thing for firm 2. Can you see? Firm 2 also faces the same demand curve, which is P equals to 30 minus Q, such that Q is equal to Q1 plus Q2. Okay? Therefore, if I want to find revenue for firm 2, what should I do? Price times quantity for firm 2, isn't it? Q2. Alright? So here, I use red pen. Total revenue 1 becomes 2. P times Q1 becomes 2, isn't it? This one becomes 2. And then this one becomes 2. This one becomes 2. This one still the same, isn't it? So this one becomes 2. 2. 2. Okay. 2. Isn't it? 2. 2. And then this one becomes 2. This one becomes 1. 2. 1. 2. 1. Isn't it? I can do this because marginal cost of them are the same, demand that they are facing are the same. Okay, but what I want you to do is that when you do for firm 2 reaction curve, you do from the you do from the beginning. That means you have price equivalent to 30 minus Q, which is 30 minus Q1 minus Q2. You must find total revenue for firm 2, P times Q2, which is 30 minus Q1 minus Q2 multiplied by Q2. Simplify it further. From here, you differentiate total revenue of firm 2 with respect to Q2. You get what? And then this is marginal revenue for firm 2. And then profit maximizing condition, okay, is MR2 equals to MC2, isn't it? What is MC2 in this case? It is given also, in which so happens that it is the same as MC1. So you just equate it to 0. Get whatever answer you get here, put it here, and then equate and then rearrange. And then you should get firms to reaction function. Firm 2 reaction function or curve is Q2 equals to 15 minus 1 half Q1. As you can see, firm 2 quantity depends on firm 1 quantity, isn't it? So Q2 is a function of Q1. The way firm 2 react is by, changing his quantity, taking into account how much quantity firm 1 wants to produce. Okay. Now, the next thing is we need to find Coulomb equilibrium. What does it mean by Coulomb equilibrium? In this case, Coulomb equilibrium, we need to find quantity for firm 1 and quantity for firm 2. What is it? At the same time, we also want to know what's the price in the market that will be charged. Okay, so how do we do this? Recall back, we already have firm 1 reaction function. Okay, that is Q1 equals to 15 minus 1 half Q2. We also have firm 2's reaction function. That is Q2 equals to 15 minus 1 half Q1. Let's call this one expression. Let me check the equation number. 1, 2, 3. Let's call this one 3A. Let me erase for just something. 3A. Let's call this one 3B. What should we do? Substitute 3B into 3A, isn't it? So you have Q1 equals to 15 minus 1 half in bracket 15 minus 1 half Q1 multiply. Okay, So here, when you simplify, mathematically speaking, Q1 equals to 15 minus 15 over 2 plus 1 quarter Q1, isn't it? You rearrange this mathematically, what do you get? Q1 4 over 4 minus 1 quarter Q1 equals to 30 minus 15 over 2. This is simple maths actually. 3 quarter Q1 on the left hand side over 15 over 2. I'll bring it here. The space is not enough. Then you have Q1 equals to 15 over 2 times 4 over 3. You get what here? You should get 10. Find Q2. What is it? So Q2 is, you know Q1 is 10. Plug it into 3B. Then you can solve for Q2. Show all the work. Yeah, don't miss any single step. Because I'm the person who's very meticulous in terms of looking at the steps of calculation, in particular mathematics. So show all the work. Then when you substitute 10 into 3B, you solve the equation, then you're going to get quantity equivalent to 10. Here I just show you the final answer, but you need to show how do you get this 10 for Q2. Okay, now, so Kuno equilibrium, you have Q1 equals to 10, Q2 equal to 10 produced by each of the firm. And then it doesn't end here. What about the price? The price, we know that from this equation, it is 30 minus Q. And we also know that Q is actually Q1 plus Q2. Okay, so the price here is 30 minus Q1 minus Q2. That is 30 minus 10 minus 10. So what's the price? The price is also 10. But here 10 bucks or $10. Okay? So Kuno equilibrium shows you that quantity for each of the firms in this case is the same and price is 10. Why they are the same? Logically speaking, both of them face the same marginal cost. Okay? And they also face the same demand curve. That's why in mathematically speaking, they also produce the same thing. Be careful, if marginal cost 1 is not the same as marginal cost 2, do you think that the quantity Q1 here will be the same as Q2? It won't be, believe me. So be careful, don't skip the step when you do the mathematics. Do it from scratch for every single thing here. Okay, don't be so overconfident, yeah? So be careful when it comes to mathematics. Okay, now, next, D, what's the total quantity produced? So here, I have answered A, B done, and then here, C done. And then for D, the total quantity is Q, 1 plus Q2 equals to Q, isn't it? In this case, 10 plus 10 equals to 20. So the total quantity in the industry is 20. Now next, E, find the profit for each of the firm. Can you do this? Okay, I won't show you because this one is so easy to find. Find the profit for each firm. You know that the general idea or formula for profit is what? Total revenue minus total cost. Because marginal cost is 0. Okay, and let's assume that there's no fixed cost. Okay, find the profit for each of the firm here. Do it yourself. Alright, now, if you can recall back, we have the reaction function for firm 1, which is 3A. We have the reaction function for firm 2, which is 3B. And we also have the Kuno equilibrium, which is 10 and 10 for each of the output respectively, Q1, Q2. Can we show all of this in the form of graph? Yes, we can. Okay, so here is the graph. Let's say Q1 is on the vertical axis, Q2 is on the horizontal axis. Now, I want to draw firm 1 reaction function. I know that firm 1 reaction function is given by Q1 equals to 15 minus 1 half Q2. So how do I draw the curve for firm 1's reaction function? Use your simple mathematics that I have learned in the high school. There are 3 things that you must provide here. Okay, you must show, okay, whether firm 1's reaction curve is a linear one or not. How to prove it? Okay, you must show a curve is a linear one or not. There's a way to do it. Number 2, you must also show the vertical and also horizontal, intercepts. Okay, let's begin. Firm 1's reaction function is this. We want to know whether it is, linear or not. And not only that, before I forget, we also want to know whether it is downsloping, upsloping, or curvy curve. So what should we do? In order to know whether it is, downsloping or upsloping, so this is the first thing. We want to know the slope basically. So the slope here is delta Q1 over delta Q2 because we draw Q1 against Q2. That's why we find the slope this way. So we're going to get 1/2 and this is less than 0. Less than 0 means negative value minus sign here. Then it means the curve is downsloping, isn't it? I know that when the curve is downsloping, okay, it can be like this. It can also be curvy like this. It can also be like this. Number 1, number 2, number 3. Number 1 is linear. Number 2 is convex. Number 3 is concave. How do I know that my reaction function here is a linear one? Because like I told you earlier, at your level, you only learn linear demand curve and also linear curves for simplicity. How do we know that it is number 1, not number 2, and not number 3? Then what you need to do with the first derivative here is to find the second derivative. So the first one is negatively slope, yeah? So the second one, you differentiate it with respect to Q2 for the second time, minus 1/2. Do you see Q2 here? No. So when you don't see Q2, minus 1/2 is a constant. When you differentiate Q1 with respect to Q2 for the second time, mathematically speaking, it becomes 0, isn't it? So when it is 0, the second derivative is 0, it means linear curve. This is just for additional bit of knowledge, yeah? If you get this, what does it mean? We know that it is nonlinear, but what does it mean? Is it number 2 or number 3? Or instead of getting this, let's say you get this. What does it mean? Is it number 2 or number 3? So you please refer back to your maths course, yeah? Because this is basic in maths. So we know it is downsloping. But we also need to know what's the value on the vertical intercept, what's the value on the horizontal intercept. So let's find it. So here, let's say I want to find horizontal intercept. Okay, for horizontal intercept here, which is on the this horizontal axis, okay, you can see Q1 is 0, isn't it? So Q1 equals to 15 minus 1/2 Q2. So Q1 is 0. So find Q2 when Q1 is 0. So mathematically speaking, when you do the mathematics here, you show all the work, yeah? Then you can get Q2 equals to 30. Here, just jump the step, but you need to show how do you get 30. Okay, so here horizontal intercept, the point is 30, 0. Okay, what about vertical intercept? Vertical intercept is when Q2 is 0. So Q1 equals to 15 minus 1/2, 0. So Q1 is 15. So you have 0, 15. Let's say 30 is here. So horizontal intercept is 30, 0. Let's say 15 is here. Let's see. So we join the two curves, the 2 points, yeah, sorry. And we draw it linear curve. It has to be linear because we'll found the second derivative like this. Then this is what we call firm 1's reaction function or curve. Okay, let me recall back what do you need to have here when you want to draw a curve, clearly, because previously it was not very clear. Number one, you need to check the slope, okay, whether it is positive or negative or both. Number two, you need to check whether the curve that you want to draw is linear or not. If it is linear, this is the condition. If it is non-linear, it can be this, it can be this, okay? This means what? This means what? Go back to your business math. Number three, you need to check the horizontal and also vertical intercept. This is how you do it. Horizontal intercept is when the value on the horizontal axis is what? Sorry, the value of the vertical axis is 0. Sorry. And the vertical intercept is when the value of variable on the horizontal axis is 0. Then you join the curve, you get firm 1's reaction function. I also want to join firm 2's reaction curve in the same graph so that I can show you Coulomb equilibrium that we have found earlier in the form of graph. So what should I do? I use firm 2 reaction function. I draw it. How do I draw it? Using all of these conditions that I've shown you earlier for firm 1 reaction curve. It's just the same thing. So after you follow all of these conditions of drawing a graph in mathematics, then you can get this firm 2 reaction curve. Let's say 30 here and 15 here. Join the 2 points. Then this is firm 2's reaction curve. Now, remember, before you can draw firm 2's reaction curve, you must show why it is downsloping, you must show why it is linear, you must show how to get the vertical intercept and also horizontal intercept mathematically. These are the proof that you must show. As an economics student, you don't just draw graph just like that without a proper justification. You must show. If you don't show, then your graph is invalid. Okay. Now, where is Coulomb equilibrium? Coulomb equilibrium is when two reaction curves here, both firms' reaction curve intersect. Because mathematically speaking, when both of them intersect, they are equal, isn't it? Okay. So here, it is at this point, call it point A. What's the value here? 10. We found it already. What's the value here? 10 also. Okay. So that's the Coulomb equilibrium. Okay. If you see Coulomb equilibrium here, both firms compete among each other, isn't it? But what happens, instead of competing among each other, firm 1 and firm 2 collude. Do you remember the concept of collusion? Both of them want to produce and sell at the same price level so that they can maximize profit. Why? Because if they collude, they are united, then they can sell more. Okay, they're stronger. So mathematically speaking, what should be done here in order to collude? It's actually simple. We go back to this profit function. Price function. The demand that both firms face in the market is this, isn't it? Once they collude, these two firms behave as a monopoly. They become one. Okay? So P equals to 30 minus Q. I rewrite it again here. Once they collude, that means total revenue for them are combined. Mathematically speaking, that is P times Q equal to 30 minus Q. But they don't, have the same management, but they just want to collude. Times Q. So here you get what? 30Q minus Q squared, isn't it? So you have the total revenue for the whole, both of them. So what should be done here? Let me erase this here. When it behaves like monopoly, the way you find profit maximizing quantity is also like monopoly method, mathematically speaking. So let me show you here. So once we find the total revenue for both of them that behave as one firm, so can you see the way we find it is just the same here. But remember, both of them, total quantity is Q1 plus Q2. That one is later, yeah, I'll show you later on this. But once we get total revenue, you need to maximize profit, isn't it? Maximize profit for monopoly, MR equal to MC. I say monopoly for these two firms because they collude and they behave like monopoly when they collude. That's why I say, the calculation is the same as monopoly. So here, what's the MR? The delta TR over delta Q, not Q1, Q2, yeah? It becomes 30 minus 2Q. And then profit maximizing is MR equal to MC. We know that MC for each of them is equal to 0. So here, 30 minus 2Q equals to 0. When you do it mathematically, 30 equals to 2Q, isn't it? And Q equals to 30 divided by 2, which is 15. This is the total quantity produced in the market or industry. But we know that even if they behave as one, they need to know each of them how much quantity they need to produce when they collude. Let me ask you, if you are from 2 and I am from 1, and we both collude, we face the same marginal cost here. Do you agree if we collude? Okay, we know that total quantity that should be produced to maximize our whole profit is 15. Do you agree if I say to you, okay, we collude, we know that total industry quantity is 15, I produce 10, you produce 5. Would you agree? No, isn't it? Nobody wants to have such kind of collusion. It's called stupid. Okay. Now, anyway, what if I say to you, okay, I produce 8, you produce 7? Of course, you don't agree. Why should you produce, 7, I produce 8, when both of us are facing the same marginal cost? If that is the case, may as well. I don't collude with you. I work alone here. So what's the the solution here is that both of us will agree to produce the same quantity. So here we know that Q equals to Q1 plus Q2. So we divide here, Q1 equals to 15 divided by 2, 7.5. So Q2 is also 7.5 because 15 minus 7.5 is also 7.5. Then that's fair, isn't it? If we compare collusion and Kuno, what can you say? In Kuno, all right, we produce 10 each, but in collusion, we produce 7.5. When you collude, you restrict quantity, remember? Can you check what happens to the price here? So price here, when we collude, price is what? 30 minus 15, isn't it? Minus total output, which is 15. Price is 15. If you can recall back, if we have Kuno, price is 10. But now when we collude, when we reunite, we charge higher, but we produce less, isn't it? When we have Kuno equilibrium, we compete, we charge less, that is 10. We produce more, isn't it? Can you calculate profit when you do collusion here? Profit for each of the firm. Okay? And what do they get? I'm sure you will find that profit of collusion is even more than the profit of having Kuno or competition, isn't it? That's why collusion is preferable compared to competition. But what's the risk of collusion? You have learned this before. The very risky, risky thing about collusion is cheating. If let's say I'm dishonest, you are honest, what I'll do? Instead of charging 15, I may charge lower than that, so that every customer comes to me, and you will be having nothing here, isn't it? Because you keep, charging at 15, believing that I'm still honest with you in collusion agreement. Okay, so what I want you to do for collusion here, you know what's the quantity produced. You already know the price charge. Can you find the profit? What you should do here is that compare and contrast between Kuno equilibrium results and also collusion. What are the things that you need to compare and contrast? Quantity produced by each firm, price charged by each firm, total quantity produced in the industry, and also profit for each firm. If you have all of this information, you can compare and contrast between Kuno and also collusion, and you can decide which one is better. Usually, if we unite is better than working alone, isn't it? We have seen Kuno, and we also have seen collusion. Here, I want to emphasize, in Kuno equilibrium, each firm correctly assumes the amount that its rival will produce, yeah, and so it maximizes its own profit based on this assumption. As a consequence, neither firm will move from this kind of equilibrium. So when neither firm move from this kind of equilibrium, then we can say that this equilibrium is efficient. So usually, when each firm can correctly assume the amount that its competitor or rival will produce, that means he has perfect information about what his competitor is doing. Okay, so we want to move to the new model of oligopoly. It is first mover advantage. First mover advantage is also known as Stackelberg model. So in the Stackelberg model, let's say we have duopoly, firm 1 and firm 2. What does it mean by first mover advantage? It means, let's say firm 1 is the first mover. Firm 1 will decide first on how much quantity it wants to produce. Then only firm 2 decide how much quantity it wants to produce. Okay, so here I want to show you that if you become a first mover, you will receive some advantages. So that's why a lot of firm wants to become the pioneer or the first mover in it. Okay, so let's say we use the same demand curve from previous example, yeah? It is P equals to 30 minus Q. And remember, Q is actually Q1 plus Q2. Why? Because we have two firms in this oligopoly model or duopoly. Also, we use the same, marginal cost as previous questions. MC1 is 0, MC2 is also 0. Therefore, both MCs are the same. Now, can you recall back what is the firm 2's reaction curve? So the firm 2 reaction curve is given by Q2 equals to 15 minus 1 half Q1, isn't it? Alright, now, remember, firm 1 is the first mover. So firm 1 will decide how much quantity it will produce in order for it to maximize profit. So here, let's say firm 2 reaction curve, we call it equation 1. Now we want to find total revenue for firm 1. Okay, so total revenue for firm 1 is actually what? It's actually equivalent to price times quantity 1, isn't it? Now in this case, it is actually 30 minus Q1 minus Q2, isn't it? Multiplied by Q1. Okay, if we simplify it, 30 Q1 minus Q1 squared minus Q1 Q2. Okay, can you see? Although firm 1 is the first mover, firm 1's decision on how much output it wants to produce also depends on firm 2's quantity. In other words, it also depends on the reaction firm 2 will show after firm 1 moves. How do we know? Because you can see quantity from firm 2 is there in the total revenue of firm 1. So, since firm 1 wants to maximize profit, maximizing profit is MR1 equals to MC1, isn't it? Now, what do we need to do? We need to find marginal revenue for firm 1 from total revenue firm 1. Now, let's call this total revenue firm 1 as equation 2. Before we do that, what we need to do is that, because like I said earlier, firm 1's revenue depends on firm 2 reaction. How do we know? Because we can see Q2 here. Q2 is given by equation 1. Okay, so what do we need to do before we can find MR1? What do we need to do is substitute 1 into 2 so that we can simplify total revenue for firm 1. So in this case, if you do mathematically, I won't show you, but if you plug in, equation 1 into equation 2, then you're going to get something like this. 15Q1 minus 1 half Q1 square. Okay? You need to show how to do this mathematically speaking, yeah, because here I just jump into the answer. Just need to substitute Q2 into equation 2, simplify it, then you can get this one, call it equation 3. Now what should you do with equation 3? From equation 3 you can find MR1 because we want to maximize profit for firm 1. So what should we do? Differentiate total revenue for firm 1 with respect to quantity for firm 1. What do you get? You're going to get 30 minus 2Q2. Okay, sorry. 30 minus 2Q2, 2Q1, sorry, over 2 here. So when you simplify it, this one is also 15 actually. Sorry, this is a mistake. Let me rewrite it again. I differentiated different equation basically. So 15Q1 becomes 15. This one becomes 2 over 2Q1, isn't it? So if you simplify it, it becomes MR1 equals to 15 minus Q1, isn't it? Alright. Now, what should you do next? You maximize profit, you follow this condition. Okay? And we know that MC is equal to 0. I bring the calculation here because I don't have enough space. So MR1 equals to MC1, maximizing profit. MC1 is 0, MR1 is what? 15 minus Q1. This one is MR1, yeah? Okay. If you simplify it, then you can see Q1 is 15. Can you find Q2? Of course you can. Substitute Q1 that you have found, which is 15, back into equation 1, then you can get Q2. Do this as this is a simple mathematics. So I just show you final answer. So Q2 here becomes 7.5. But when it comes to exercises, you need to show how do you get this 7.5, yeah? Because here I just jump into the final answer. You need to show the work. Now, next, what about the price? We know Q1 is 15, we know Q2 is 7.5. What about the price? Price is this function, isn't it? You substitute Q1 equals to 15, Q2 equals to 7.5 back into this equation because Q is equal to Q1 plus Q2, isn't it? So here, P equals to 30 minus Q1, which is 15, minus Q2, which is 7.5. Okay, so what do you get? 7.5. Right. Now, can you see? If you are firm 1 and I am firm 2, do you get any advantage being a first mover? Of course, because the quantity produced Q1 is bigger than Q2, 7.5. That is not enough, yeah? You need to look at the profit of firm 1, what is it? The profit of firm 2, what is it? Compare it. Then you can see clearly the advantage of being the first mover. Okay? This is the conclusion that we can make, but you have to calculate profit and compare. You need to compare quantity, then you can conclude what happens to the first mover. Why firms really wants to be the pioneer or the first mover. Remember, try to find the reason how a firm can be the first mover. You have seen the oligopoly model that determines the profit by looking at the quantity. So you have seen Kuhn model, you also have seen Stackelberg model, and we compare it with collusion. Now, what if the competition among the oligopoly firm, instead of quantity, it is price? Then we are talking about the third model, which we call Bertrand model. Now, the Bertrand model has been introduced by a French economist. His name was Joseph Bertrand. So, Bertrand model is actually an oligopoly model in which each firm treats the price of its competitors as fixed. If we look at Kuhn model, we see that in Kuhn model, each firm treats the quantity of its competitors or rival as fixed. And then same as Kuhn model, although they are Bertrand using price, each of the firms will decide, okay, simultaneously with other firms what price to charge. Yeah. So how to find Nash equilibrium in Bertrand model? Okay, we want to know about the method to find equilibrium in Bertrand model. We also want to know what price will be charged by each of the firm and what quantity they will produce. Okay, what's the total output in the industry and what's the profit earned by each of them. And here, like I said earlier, what's the difference between Bertrand and also Kuhn model? As I said, in the Kuhn model, the competition is about the quantity, but in Bertrand model, it is about price. So in Bertrand model, it's about price war, but in Kuhn model, it's about quantity war. Now, the Bertrand model, when it comes to the product produced, it can be homogeneous, it can be heterogeneous. What I want you to do is to look at the example from the textbook on homogeneous products. Yeah, you try to figure out how the calculation is made. Here, I want to show you the Bertrand model, that is price competition with heterogeneous product. I'm sure by now you should know what does it mean by heterogeneous product. So let's say we have two firms, yeah? So we have duopolies, and each of them has fixed cost of 20, but they don't have variable costs. Now, what's the implication of not having variable costs? The main implication is MC is equal to 0. So that means MC for firm 1 equals to 0, MC for firm 2 is also equals to 0. And let's say we have firm 1's demand function that look like in the expression 4, and firm 2 demand function is in expression 5. If you can see the pattern here, each firm faces the same demand curve. Now you look here, quantity as a function of price. In the previous example, price as a function of quantity. What's the difference between these two types of demand function or demand curves? Demand curve here and here is what we call direct demand function, but the demand function that in which price depends on quantity is indirect demand function. Now let's crack on. So like I said, this is a price war or price competition. So we need to do it one by one. Although both of them simultaneously decide, when it comes to calculation, we do it one by one. Let's begin with firm 1. So what we need to do here is to find firm 1's profit, because we want to find a price that could maximize profit. So here, remember our objective, or firm 1's objective, is to maximize profit. But firm 1 needs to find what? Is it quantity? No. It is price that can be used to maximize profit. Previously in Kuhn model, it was quantity that can be used to maximize profit. So that's why in Kuhn model, we did delta profit over delta Q, isn't it? We can also have delta total revenue over delta Q. We need to find delta C over delta Q, isn't it? You look here, Q. But here, because we need to find the optimal level of price that can maximize profit, so that means what? Our objective here is to maximize profit, But our argument here is no longer quantity. Our argument here is price. Alright, so let's find profit function for firm 1. So profit function for firm 1 is actually what? Price 1 times Q1 minus total cost 1, isn't it? What kind of cost do we have? We only have total fixed cost plus 0 variable cost, then it becomes total cost, isn't it? So in this case, for firm 1, it is 20. Alright, so let's simplify it further. We know that Q1 is given by expression 4, so we rewrite it here. P1 times Q1, which is 12 minus 2P1 plus P2 minus total cost 1, which is 20. Okay, so here if I simplify it further, I get 12P1 minus 2P1 square plus P1, P2 minus 20. So this is my profit function for firm 1. Now, from this profit function, we need to maximize profit. Mathematically speaking, what should we do? To maximize profit for firm 1, mathematically speaking, we need to find first order condition for firm 1. So, first order condition for firm 1, what it is delta P1 over delta P Latin word here equals to what? You differentiate all of this using your mathematical knowledge that you have learned in your first year. 12P1 becomes 12. 2P1 square becomes minus here 4P1, isn't it? P1, P2 becomes P2 minus 20 becomes 0. And then what should you do? Because this is first order condition, then you should equate it to 0, remember? Okay, so we have what here? The first one on the left is actually marginal profit, isn't it? And this is actually marginal revenue for firm 1. And this is actually marginal cost for firm 1. And then equates it to 0 minus. So marginal profit for firm 1 is actually equivalent to marginal revenue for firm 1 minus marginal cost for firm 1 and equate it to 0. Then that's why we can get, I break it here, yeah? That's why in the profit maximizing condition, we can have MR1 equals to MC1. Okay, so in this case, 12 minus 4P1 plus P2 equals to 0. From here, if we rearrange it, we can get what? We can get firm 1's reaction curve. Okay, so when you rearrange it mathematically, please show all of the work. Okay, so you're going to get 4P1 equals to 12 minus P2, isn't it? Okay, so P1 equals to 3 plus 1/4 P2. So this is firm 1 reaction function. Okay. So from here, let's go back to the question. We have found firm 1's profit function. Okay. We haven't found firm 1's profit maximizing price, but we have found C, firm 1's reaction curve. In order for us to find B, firm 1's profit maximizing price, we need to find price, yeah? We need to work on firm 2's reaction curve. Okay, how do we work on firm 2's reaction curve? We do the same as the way we found reaction function for firm 1. That means you need to find profit function for firm 2. After that, you need to differentiate profit function for firm 2 with respect to price for firm 2 and then equate it to 0 because this is first order condition to maximize profit of firm 2, isn't it? From here, you can derive firm 2's reaction curve. Now, when you derive firm 2 reaction curve, you're going to get something like this. P2 equals to 3 plus 1/4 P1. I call firm 1's reaction function as, equation 1, this one equation 2. So let's say the first one here, profit function here, is actually equation A. Okay. All of the process here is more or less the same as the way we find firms 1 reaction function. Yeah, I'm talking about firms 2 reaction curve. But I want you to try it at home. How do you get equation 2? Now, once we get equation 1 and equation 2, we can solve the question of what's the firm 1's profit maximizing price? What is the price that can maximize firm 1's profit? What should we do? We substitute equation 2 here back into equation 1 so that we can solve for the price charged by firm 1. So here P1 equals to 3 plus 1 quarter P2. P2 is 3 plus 1 quarter P1. Okay, when you simplify it, you have some steps that you need to follow. Then you're going to get something like this. P1 equal to 16 over 4, which is 4. Okay, now the step in the middle here, I want you to figure it out. Okay, because I've shown you the second last step and also the last step. I want you to figure out how to get from P1 equals to this up to the last line here. What about P2? If you do the same, you're going to get, 4 also. Okay, this is simple maths. This is just a simple maths here. Now, what do you need to do next? You have found price. You have found a price for 2 firms, firm 1 and firm 2. You need to find the quantity. The quantity here is 12 minus 2 P1 plus P2. So you have 12 minus 2 times 4 plus 4. What do you get here is, okay, what do you get for this? 12 minus 8 plus 4 is actually 8. Okay, 12 minus 8 becomes 4. 4 plus 4, 8. What about Q2? You're going to get same answer, but you need to show how do you get this. Don't you wonder why do these two firms receive the same answer for price and also quantity? That is very simple. It's just about mathematics. It is because the demand functions are the same and also they don't incur marginal costs. Not only that, the total fixed costs are the same. Should there be any differences in any one of these, then the result won't be the same. Yeah, that's why I really want you to go through all the steps without missing any single steps. Don't just assume that if reaction function of firm 1 looks like this, then reaction function for firm 2 will always look like this. It depends on whether your marginal costs are the same for both of them, and what about the marginal revenue? Is there any difference in total fixed costs? Is there any difference in assumption and whatnot? So you have to do it from scratch. Don't just jump into conclusion. That's why I really reminds you many times, show all the work when you do calculation, yeah, because otherwise you may tend to make a silly mistake here. Okay, so here what we can say, if I were to summarize, okay, P1 is equal to P2 equals to $4, isn't it? Q1 equals to Q2 equals to 8, isn't it? And what about profit? Profit 1 is equals to what? Profit 2 equals to what? If you calculate, profit 1 will equals to $12. Profit 2 will also equals to $12. Try to find out how to calculate the profit here. I've given you the answer. Alright, so this is price war. Yeah? Each and everyone charge 4. Each and everyone produces 8. And each and everyone receive profit of 12. So here you can see total profit in the industry is what? Total profit in the industry is Q. Q equals to Q1 plus Q2 equals to 8 plus 8 equal to 16, isn't it? What about the total profit in the industry? It is 12 plus 12, isn't it? Okay. What about the price in the industry? It is always 4, not 4 plus 4. Remember that. Alright. So we are done with Bertrand model for heterogeneous product. What if these two oligopoly, instead of having price war, they have collusion? The question is, when they have collusion, what happens to the price level? Okay, what happens to the quantity produced by each of them? What happens to their profit? Alright, in this case, we already know that for any kind of firm who wants to collude, what they will do is that they will charge the same price. Why? Because each of them is facing the same total cost, isn't it? Alright, now here, I'll show you how. So in this case, total cost for both firm 1 and firm 2 are the same. Okay, and hence, that's why the price charged by each firm is the same. What am I talking about? This is the case for collusion. Okay, I assume that instead of having price war, these two firms, firm 1 and firm 2, wants to have collusion to charge at the same price level. Why? Because if you can recall back your study in Principle of Micro, when you collude, when you unite, you can charge higher, you can restrict quantity, you can make more profit. Alright, now because of that, then P1 equals to P2, isn't it? And then we use one notation only so that we don't have P1 equal to P2 all the time. We use P. Alright, so what we need to do here is that when they unite, we need to find the price, we need to find the quantity. Okay, when they unite, what price will they charge in order to maximize profit? So what we need to do is to add all of the profit here. So in this case, we have total profit equals to profit from firm 1 plus profit from firm 2. Okay, now profit from firm 1 is actually total revenue from firm 1 minus total cost from firm 1, isn't it? Now what is total revenue for firm 1? P times Q1, isn't it? I use P because now they have the same price. So I just use one notation so that we don't have to write P1, P2 when it is all the same actually. Minus total cost, which is 20, isn't it? Now, Q1 is what? If you can recall back, this is Q1. 12 minus 2 P1 plus P2. So 12 minus 2 P1 minus 2 P1 plus P2, and then minus 20. When you simplify, you have 12P minus 2P plus P squared, isn't it? Minus 20. Okay, so here, why? Because now, it's no longer P1 and P2, it's all P. Now, let me fix something here. Square is missing here, isn't it? Okay. Remember, before I proceed, so that some of you are not confused, when we collude, alright, these two firms, you recall back, both of them have the same total cost. That is total fixed cost, 20, each of them, isn't it? And therefore, when they collude, it is possible for them to charge the same price level, isn't it? Alright? So when price charged by each of the firm is the same, that means P1 equals to P2 equals to P. I put P here so that instead of writing P1 equals to P2 or whatever, then I just use one letter P. Okay, now, in order to collude, like I said earlier, alright, this firm will try to find the price that can maximize their profit. So what I did earlier, I joined the profit for both of them. Then, then I can differentiate and get the first order condition and whatnot to find the price. But in the total profit, you can see is equals to P1 plus P2, isn't it? Profit from firm 1 plus profit from firm 2. Now, for profit for firm 1, it is total revenue for firm 1 minus total cost from firm 1. It is P times Q1. Of course, it is P1 times Q1, but because P1 is now being, written as P instead, so I put P only. Minus 20 is the total cost, and total cost here is only total fixed cost. When I simplify, okay, after some corrections, then I get this. Right? Now, what about profit from firm 2? Okay, it is also total revenue minus total cost for firm 2. It is P times Q2 minus 20 also, isn't it? Because 20 is the total fixed cost for firm 2. Alright, now, and when you simplify, you're going to get something like this. 12P minus 2P squared plus P squared minus 20, isn't it? Okay. So when you add up both of them, you simplify further, what do you get? You're going to get something like this. 24P minus 2P squared minus 40. Okay. So you look here, we have found the total profit for both firms. Now what we can do is, remember, these two firms are colluding among each other. They want to charge the same price level. They are united so that they can increase their profit. So what should we do next? Of course, we need to find, first order condition for this profit function that has been combined for both firms. Now let me bring it here. Let me rewrite again the profit function. Total profit function here is 24P minus 2P squared minus 40. Maximizing profit means you need to find first order condition. Delta PT over delta P equals to what? 24P becomes 24. Minus 2P squared becomes minus 4P. Minus 40 becomes 0. First order condition means it must be equal to 0. This one is actually marginal profit total. This one is actually marginal revenue. This one is actually marginal cost, isn't it? So here we can have marginal revenue equals to marginal cost. 24 minus 4P equals to 0. When you solve it, show all the work, yeah? You're going to get price equivalent to 6. Okay, so each of the firm, when they collude, they charge price equivalent to 6. Now, from here, can you calculate what's the quantity they each of them produce when they collude? Can you also calculate the profit for each of them when they collude? I give you answer, the final one, but you need to check the calculation. You need to show each and every single work. So profit for the first firm is 16. Profit for the second firm is 16. Okay. So when you collude here, P1 equals to P2 equals to 6. Quantity, what is it? You need to find it. And profit here is 16. Profit for firm 2 is also 16. So this is collusion. When you compare with price war, price is 4. 4 is less than 6, isn't it? Quantity is 8. Okay. Profit is 12. Profit 12 from price war is lesser than profit from collusion, which is 16. Alright, which one is better? Obviously, collusion is better than having a war. Alright. If we try to put both of them in the form of graph, All right. Remember, we have Bertrand and also collusion. So here, I want to put the reaction function for firm 1 and also firm 2 in the same diagram so that I can show you the Nash equilibrium for Bertrand. So instead of Q1, it is P1 on the vertical axis. Why? Because we are talking about Bertrand. We're not talking about Coulomb. And on the horizontal axis, it should be P2. You recall back, reaction function for firm 1 is P1 equals to 3 plus 1 quarter P2. And reaction function for firm 2 is 3 plus 1 quarter P1. If I want to draw a reaction function for firm 1, what should I know? First, I should know the slope. Okay. Second, I should know whether it's linear or not. The third, when I want to draw, I should know whether it has vertical intercept or not, whether it has horizontal intercept or not. Is it clear? How do I do all of this? I have shown you earlier when I draw, reaction function in the Coulomb model. So when you want to draw a curve, you must prove that it is upsloping or downsloping. Second, you must prove that it is linear or nonlinear. Number 3, you must show the value of vertical axis or horizontal axis if both of them exist. Alright, so here, after you do all of these 3 things, the requirement to draw graph in mathematics that you should show, here I just jump into the, into the last step here, because I expect what you have learned in the high school in terms of showing the slope, showing the linear or non-linear, the proving, in terms of how to find the vertical axis and horizontal axis and how to write it properly when it comes to exercises. You already learned it in the high school, so I won't repeat it again. Here I just jump to the step, the last step. So when I draw reaction function for firm 1, it may look like this. So it is linear and it is upsloping. Check how to know that it is linear. Check how to know that it is upsloping. So this is firm 1's reaction curve. Okay. So firm 1 reaction curve is actually what? P1 equals to 3 plus 1 quarter P2, isn't it? The value here would be what? When P2 is 0, P1 is what? 3. Okay. Now, if I have another one here, I may have another one because I need to draw reaction function for firm 2. Otherwise, I cannot find the Nash equilibrium in the form of graph. We have found the Nash equilibrium in the form of mathematics, but we want to show it in the form of graph as well. So this one is actually firm 2's reaction curve or function. It is P2 equals to 3 plus 1 quarter P1. Okay, what's the value here? Okay, it is when P1 equals to 0, then this one is 3. If you see the intersection here, this is what we call equilibrium in the Bertrand model. We have found the answer mathematically. We know the answer for P1 is 4, P2 is also 4. Now this one is actually the Nash equilibrium. Right? And we can also put the story of collusion, yeah? Collusive equilibrium. We found that in collusion, price P1 and P2 are the same, and it is higher than price when they have price war. What's the price in the collusion? It is 6. So perhaps 6 is here. Okay, so because it should be above 4 and 6 is here. So there you go. Okay, so 6 is here. And this point Let me change it to yellow. This one is actually collusive equilibrium. Alright? Can you see? For the collusive equilibrium, it is higher than the price war equilibrium or Nash equilibrium for Bertrand model. Let's summarize what we have from the analysis of Bertrand and also collusion. For Bertrand, okay, we have two firms. The price charged by two firms, P1 equals to P2 equals to 4, isn't it? And we also found that profit for firm 1 is equal to profit for firm 2 equals to 12. But when they have collusion, price charge is also the same. However, it is higher. And profit they found, they receive is 16, which is higher than having price war. Now you look here, the risk of having collusion is a cheating problem, isn't it? So let's say we have cheating problem here. We have two firms, firm 1 and also firm 2. Let's say firm 1 cheats, okay? And firm 2 stay honest. Now if firm 2 stay honest, that means firm 2 price is 6, isn't it? Now you imagine if you are firm 1 and you want to cheat in this collusion, what price will you charge? Do you just charge by choosing the the cheaper price without any justification? No, it can't be. Remember, whenever you do business, whatever action you want to take, you always remember that you want to maximize profit in it. You want to maximize profit by cheating, so you know that you must charge lower than $6, but then you have to make sure that that lower price must give you maximum profit, isn't it? So what is the lower price that can give you maximum profit? The lower price than 6 that can give you maximum profit as a firm 1 is 4, isn't it? Because you have tried that by having 4, you can have, a bigger profit, of course, when firm 2 honest. Okay, so let's say firm 1 charges a 4. Now, can you calculate profit for firm 1? Can you also calculate profit for firm 2? In this case, if you calculate it properly, then you can see profit for firm 1 will be 20. But what about profit for firm 2? It will be 4 only. So can you see, if firm 1 cheats, firm 1 get bigger profit than, collude. The lowest profit ever is if you have price war competition. Now, is it possible if we twist it? Instead of firm 1 cheats, firm 2 cheats. If firm 2 cheats, of course firm 2 also charges 4, isn't it? Because that's the price that can give maximum profit if he cheats. And firm 1 honest, so firm 1 price is 6 because firm 1 maintain the collusion. And if you calculate the profit for firm 2, it's going to be 20. Try to calculate it. How do you get this 20? And firm 1 will only receive 4. Okay? You have price war, you have collusion, you have cheating. All of this information can be used to come up with what we call payoff matrix. So here, let me show you the payoff matrix. Now, the payoff matrix for pricing game for this case is, you see here, firm 1 has two strategies. What are those two strategies? Either to charge 4 or 6, isn't it? Same also, goes to firm 2. Firm 2, you can see it can charge 4 or 6 as well. If we have price war, both firms will charge 4, isn't it? And you can see the first cell here. This is the first cell. The first cell here, 12 refers to profit by firm 1. Another 12 here refers to profit for firm 2. But if firm 1 charge 6 and firm 2 charge 4, firm 2 receive 20, firm 1 receive 4. But if firm 1 cheats, firm 1 charges 4, firm 2 charges 6, then firm 1 receive 20, firm 2 receive 4. This is cell number 2, cell number 3. Okay, now lastly, if both firms charge high, they collude, they charge 6, and each of them receive 16. This is cell number 4. Now, P of matrix is basically a table that shows P of, in this case business, the P of is profit, to each of the player. In this case, the player is firm, given its decision and the decision of its competitors or rival. In this case, if I'm firm 1, I have my own decision, and I also look at your decision, firm 2's decision, my competitor, and vice versa. In this payoff matrix, we can see 3 different things basically. The first one is non-cooperative game. What does it mean by non-cooperative game? It is something that you have seen earlier. Bertrand is an example of non-cooperative game in which everybody is competing among each other. You don't have any collusion at all. So, non-cooperative game is a game in which negotiation and enforcement of binding contracts or collusions are not possible at all. Okay. If we have cooperative game, what does it mean by cooperative game? You have learned it before, it's just that you learn it using different terms. It is collusion. In this case, we have seen that if two firms collude, when they cooperate among each other, okay, with a certain negotiation and enforcement of binding contracts, then you can see both of them will charge high, 6, and each of them will receive profit 16 and 16 respectively. Okay. Now when we talk about payoff matrix here, it is a very famous matrix in the study of microeconomics. And the study of microeconomics is very wide. It can be divided into different types. You can talk about industrial organization. You can also talk about game theory. So game theory is related to oligopoly industry, and game theory mainly uses payoff matrix like this. Okay, there is one subject called game theory at the higher level of undergraduate in other universities, especially in advanced countries. And this game theory is an extension of intermediate microeconomics too. Okay, now, so game theory, the payoff matrix here, comes from the story of prisoner's dilemma. Now, prisoner's dilemma here is actually a game theory example, yeah, in which, if let's say we have two prisoners caught because of crime, okay, did by them before that, okay, so we have prisoner A, prisoner B, and they are put in different cells, okay, and then they must decide separately, okay, whether to confess or not to confess to a crime. So, let's say prisoner A confessed and prisoner B doesn't want to confess. So what happens here is that prisoner A will get a lighter sentence, but prisoner B will get a heavier sentence. However, if both A and B do not confess, then they receive lighter sentence compared to if they both confess. Can you see, if you are prisoner A or B, you have this kind of dilemma, isn't it? To confess or not to confess? Okay, so the payoff matrix basically uses this kind of example to understand about the game in the industry. So if I give you example of payoff matrix for prisoner dilemma, it is like this. So here you can see payoff matrix for prisoner's dilemma. We have prisoner A, we have prisoner B. Prisoner A has two strategies, to confess or not to confess. Prisoner B also has two strategies, to confess or not to confess. And you can see all of the numbers inside the matrix here, -5, -10, -1, are the payoff or are the reward. Why it is minus? Minus refers to how long you'll be in the jail. If we have -5, -5 is higher than -1 in terms of the duration staying in the jail. Okay, so I'll show you more about this in chapter 13 later, especially on the right way of reading payoff matrix. There are many implications of the prisoner dilemma for oligopolistic pricing. So one of it is price rigidity. I'm sure you have heard the term price rigidity when you learn in Principle of Microeconomics, because it leads to what we call kinked demand curve. So these two things cannot be separated at all. Now let me show you in the form of graph how do we derive kinked demand curve and how price rigidity can be explained using kinked demand curve. So let's look at this frame of diagram in graph 7. So we have price on the vertical axis and we have quantity on the horizontal axis. Now we have two different types of demand. The first demand is D1. Let me show you. So this is D1 and the associated MR is MR1. Okay. Let me use different pen now. We can also have another demand curve which is much steeper than D1. So let's say, okay, this one. I call it D2, the blue pen. And the associated MR is MR2. Okay, so this is MR2. Right. Now let's use red pen. We look at the intersection between D1 and D2, it is here. Okay, what I'll do is I'll divide the graph into two segments at the intersection point. So this is the first segment, this is the second segment. Okay, now how to derive kinked demand curve? Let's look at the first segment. You have D2 as a blue line, D1 as a black line. You look at D2, if the firms choose the price at D2, it is very obvious the price at D2 in the first segment is higher than the price at D1, isn't it? Alright, so if you are the firm in the oligopoly industry, you may want to choose D1 in the first segment. Why? Because D1 here is cheaper and you can have market share. So if you choose D1 in the hope that others will follow suit, so we take this, yeah? And let's move to the second segment. In the second segment, D1 is above D2. Therefore, any prices on D1 is higher than any prices on D2. If I'm the firm, I'll choose to charge at D2 instead. And I hope others will follow suit. Okay? So because if I charge D1, nobody will follow because they know that if you charge D1, you cannot make profit. So you choose D2. So this one. Okay. So D1 in the first segment here, the associated MR is this one, isn't it? Okay. Until the dash point here. And for D2 in the second segment, the associated MR is this one, isn't it? Okay. So you have created a kinked demand curve. Let me use orange to highlight it. Yellow, yeah. So this is the kinked demand curve. Okay. And the associated MR is this one. After this, and then here. Okay. As you can see, the MR at this point, call it Q star. There's a gap there. Okay, why? The gap exists because of the king point here. So what's the determination of the price? Let's say MC falls within the gap. So this is our MC. When MC falls within the gap, so MC equals to MR at the gap itself, isn't it? Within the gap itself, then the price will be at the king point, call it P star, and the quantity will be Q star. There's no tendency for all firms in the industry to change the price. Why? Because if you increase the price above P star, nobody will follow. If you decrease the price in the second segment, okay, then you are making losses and no one can survive. So the price becomes rigid at P star here. Okay. So as you can see here, each firm believes that if it raises its price above the current price P star, none of its competitors will follow suit. So you will lose most of the sales because other competitors are selling lower than you. At P star, you are selling above P star. So customer will come to them, not to you. So you're losing sales. So each firm also believes that if it lowers price, everyone will follow, isn't it? To the extent that the market demand increases. So when market demand increases, the share of everyone becomes smaller also at the same time, yeah? Because too many following reduce in the price. As a result, the firm's demand curve D is king at this point, call it point A, okay, at the price P star, and its marginal revenue has certain gap here between this and this, okay. This continues at that particular point, isn't it, between B and C. So if marginal cost increases within this gap, the price still stay at P star, quantity still stay at Q star. So that's the demand curve here. So as you can see, when we talk about price rigidity, it comes from the dilemma whether to increase or to decrease the price. Now let's move to another different concept in oligopoly. We call it price signaling and also price leadership. These two kind of things is the implication of king demand curve and also price rigidity. Now, what does it mean by price signaling? You look at the word signaling, it comes from the word signal. In certain countries, collusion is not allowed at all. You can be sued, you can be jailed because you do collusion with others. Now, because of that, then some firms, they do it implicitly or secretly. So how do they do it? If I'm firm 1 and you are firm 2, I give a signal to you, I increase the price in the hope that you will also increase the price following me. Okay, so that is price signaling. So it is a form of implicit collusion actually, in which a firm announces a price increase in the hope that other firms will follow suit. How the firm announces a price increase? Usually you just change the price at the when you have the price tag at the at every product, you change the price there. Okay, and who wants to follow? The question is, who wants to follow the increase in price? Usually you must have credibility to do this. You must be a leader. Then we also talk about what we call price leadership. Now, what is price leadership basically? It is a kind of pattern of pricing in which one firm regularly announces price changes that other firms then match. Why other firm follows him? Follow that firm? Because other firms knows that that firm is a leader. So for instance, if we have firm A, and then we have firm B, and then we have firm C. Let's say firm A says, let's say we increase the price of pen to $2. So let's say cost of production for A, I put it here in the form of money. Cost of A is here, and cost of B is here, cost of production, cost of C is here, and the price 2 is here. And A says, I want to increase the price to 2. If you increase also, we can make a lot of profit. So will B and C follow? Okay. If B and C follow, B and C also enjoy higher revenue, isn't it? Because everybody is charging the same price. and they behave like collusion. Okay, is there any possibility for B and C to cheat? Yeah, let's say B wants to cheat, reduce here. Let's say to 190. Let's say B cheats. B do it here, and A and C stay here. What will happen next? You have to remember, if B cheats, A can do something also. A can charge, let's say here, 50, having price war, isn't it? Can B survive? B cannot survive because cost of B is here, A sells here, cost of A is here. Can you see? So in order to be a leader in the market, to do price leadership, okay, usually the cost of the firm, that becomes leader is the lowest. So other firm cannot threaten the leader. All right. An example that you can think of in reality, try to think of it, is a lot in reality basically. When we talk about oligopoly industry is a very interesting market because in that industry or market, we have different types of model that shows the behavior of firms. And the behavior of firms, all different types of model that shows behaviors of the firms only have one objective. The firm wants to maximize profit. That's all. Even if they have rivals in the industry, you can see that some firms have large market share. When I say they have large market share, that means the customers buy their product more than other firms, though other firms are selling the same thing, probably because of this differentiated product, the quality and whatnot. Then these kind of firms become dominant firms in the industry. How can we model dominant firms in the industry? Let's look at this graph. Now, let's say price is here, quantity is here. We have two different types of firms in the market. Yeah, the first one is dominant firm. The second one is what we call fringe firm. Fringe firms are actually small firms that are the followers of the dominant firms. So if we have dominant firm, usually dominant firm decide the quantity and the price first. Okay. So let's say we explain it using this graph. Let's say the total demand in the market, regardless whether it goes to dominant firm or not, or fringe firm, is this one. So this is the total demand in the market, D. And let's say the supply of fringe firms is this. So this is the supply of fringe firm. You look here, when supply of fringe firm is equal to the total demand at this price level, okay, let's call this price level P1. Okay, then we understand that all the total demand in the market is met by fringe firm. Dominant firm doesn't supply anything here, isn't it? Or doesn't sell anything here. So that means dominant firm starts to sell something when the price is below P1. And let's draw the dominant firm demand curve. Any kind of demand curve is always downsloping. So same goes to dominant firm's demand curve. So let's say the dominant firm's demand curve looks like this. Okay, now here, so this one is the demand for dominant firm. And let's say with the demand, we have marginal revenue for dominant firm, which is this marginal revenue for dominant firm. For simplicity, let's say marginal cost is linear and upsloping, yeah? So here, let's say it looks like this. So this is marginal cost for dominant firm. Don't be confused with supply curve for fringe firm. Marginal cost for dominant firm has nothing to do with the supply of fringe firm. Okay. Now, we want to see how dominant firm decide to produce and how much it wants to produce. So as usual, MRD equals to MCD, isn't it? For profit maximizing condition. Where it is, MCD is here, MRD is here. At point A. Okay, at point A, where is the price? The price is here. Let's call it P star. The quantity that will be produced by dominant firm will be here, QD. But you look here, the quantity produced by dominant firm is QD. But at P star, the total demand is where? The total demand is here. Because this is demand curve for total. Therefore, the total quantity of demand in the market should be here, isn't it? That means there's a gap. Okay, the gap between QD and QT is actually fulfilled by the fringe firm. How fringe firm fulfill it? Look at P star, it hits supply of fringe firm here, isn't it? When it hits here, then the quantities supplied by fringe firm is here. So QT is the total demand equals to QD plus QS. QS is this much, QD is this much. Add both of them, you get distance of QT. Get me? Okay. Now, just imagine if fringe firms doesn't want to supply anything, then fringe firm is here, isn't it? The supply amount is 0 at this level of price. Call it P2. Then the total demand, as you can see, will be exactly equal to demand for dominant firms. So at P2, total demand for dominant firm is equivalent to total demand in the market. And at that kind of point, supply is 0 by fringe firms. Can you see? So here, let's go back to point A, and I mean P star here. At P star, when dominant firms decide to produce at QD, you can see that QD is greater than QS. Can you see the advantage of being a dominant firm? You can produce more, you can capture more market share. That's why I said from the beginning, when we talk about dominant firm, usually this kind of firm has large market share. Whenever we talk about dominant firm, like I said just now, it is a firm with a large market share of total shares in the industry. And this kind of firm can set price to maximize its own profit, taking into account the supply response of smaller firms. Although you are a dominant firm, but you must also take into account the response of smaller firms, because the response of smaller firms can also affect your profit. Okay. Now, in reality, we have a number of examples of dominant firms in oligopoly industry. The first one is a very famous one. It is called cartels. Cartel is a kind of collusion among, among OPEC countries, for instance, or among other types of organization of production. But OPEC is the most famous one. So, cartel is actually a formal collusion, and when I say formal collusion, it is not, banned in those countries. Okay? So, producers in a cartel basically agree explicitly to cooperate in the setting prices and output level. Sometimes they restrict the quantity produced so that the price increase. Okay? So, sometimes they set the price increase so that automatically quantity also reduce. But they can still make profit. Why? Because when the price increases, total revenue increases, isn't it? And of course, for a given same amount of cost, you can increase the profit. Like I said just now, OPEC is the most famous, cartel in the world. Okay, try to study the graph. The graph is available in the textbook. If you see the graph of OPEC oil cartel, it is similar to the graph that I showed you earlier, this graph. It's just that the setting is a bit different, probably because of the elasticity itself. Okay, so if you talk about cartel here, try to look at the history. How many times over the years within, these, before 2000 until now, how many times cartel has restricted the output? How many times cartel has increased the price? But in certain years, okay, there were times where cartel, especially OPEC, did not get good price of oil. If you can remember last year, what happens to the oil? Oil has reduced. Try to figure out what's the reason. It was a very famous reason. There is another type of cartel that is very famous. It is about copper. And this is about CPEC. Try to see the history of CPEC and see how the cartel being done. Try to compare and contrast between OPEC and CPEC. Which cartel is more successful cartel and why? Because if you can understand more about cartel in reality, then you can appreciate whatever graph that I've shown you here. Of course, the graph that I've shown you here, all of these, are not 100% can be applied to the reality, because in reality, all of the things move simultaneously at the same time. In the graph here, we have two-dimension graph here. We always put other things constant or ceteris paribus. But there will be some, some points in the graph which is similar to the reality. Reality, because it's too complicated. That's why in theory, we put certain things constant, we put other things moving. Okay, so please look at the CPEC and also OPEC and see the differences between them. I may ask you in the exam. So that's all for the topic here. In the next chapter, you're going to see the the continuation of the story of oligopoly industry. I would like to emphasize you on certain thing about oligopoly industry. Oligopoly industry is very interesting, industry to be studied or analyzed, because in the oligopoly industry, there is one kind of game that is very, very famous among industrial organization economists. We call it game theory. In fact, like I mentioned to you earlier, there is a subject for microeconomics, we call it game theory, at the undergraduate level and also higher level, postgraduate level. And game theory is not just about how to use mathematics. It is more on about how do you play the game using mathematics, using economic theory. And if you're the player, you assume you're the firm who wants to maximize profit. How do you play the game in the industry which is very nasty? You want to maximize your profit, at the same time you have many rivals, and some people are cheating among each other. How do you survive in the industry? So it is a very interesting topic. It deals with a lot of, critical thinking. To some point, some people would say it's difficult, but if you're very good in critical thinking and playing the game, I mean, not about video game, but this kind of business game, then you can see the pattern, then you know the strategies on how to win the game. So that is game theory. Okay, so thank you very much.